Hello, got a few questions from you guys today, so I'll try to answer those in this screencast, and then if you guys have more questions, I'll try to either email you back or make another screencast. So the first question that I got asked about these questions that you see 17 through 19. And 17 and 18 have to do with electricity and magnetism, which we talked about briefly before the last unit on chemical reactions. And so the wording is just a little tricky, but we did talk about this. And on the final, you will have a couple questions like 17 and 18, but I'll try to reword it so that hopefully it's a little easier to understand. But 17, you probably may have looked at the answer, but it says electricity flowing through a wire into iron, cobalt, or nickel. You might remember that you guys did one of those Google forms before looking at elements that were ferromagnetic, and iron, cobalt, and nickel, as well as one that I didn't even realize, gadolinium. Those are ferromagnetic, which means they can be induced into becoming a magnet. So when you have electricity flowing through a wire, and you saw this actually in the video about E equals mc squared, Einstein's big idea, this is what Faraday had kind of made his discovery about, was he kind of realized what was happening there. And electricity flowing through a wire can create a magnet. So in terms of the effect, you might read those four and not really have a clue. Your book does talk about this, and the wording is pretty similar here as well. Electricity flowing through a wire into elements or materials that are ferromagnetic can produce a magnetic field. So that's the electromagnetic effect. So it's D, and that's all that's saying. And so again, I'll try to reword that in another way. And then 18 is saying the opposite. So when you move a wire through a magnetic field, or vice versa, meaning you take a magnet and move it through a wire, then you'll produce electricity. And so that's called the generator effect. And your book talks about that as magnetic induction. So there's different names meaning the same thing, but really what we're saying on 17 and 18 is that electricity can create magnetism, and on 18, magnetism can create electricity. So you might remember we looked at this simulation, and it's one of those PhET simulations again, and notice that the simulation is called Faraday's Law. So again, we're going back to Faraday that you saw in that video, and we're actually seeing that generator effect here. So when we take a magnet and we move it past wire, we can actually create electricity, which we're seeing in the lighting of the bulb and on the voltmeter as well. So notice that if the magnet's not moving, we don't get electricity. So it has to be a moving magnet, either moving this wire past a magnetic field or moving magnetic field past a wire. So again, that's called the generator effect because you're generating electricity. So that's the idea, using magnets to create electricity. And this is a huge deal now. When Faraday discovered it, not so much, because at that point they really didn't know how they were going to use this. Again, I think in the book it actually talks about one of the kings at that time asked Faraday, big deal, so what can you do with this? And he said his response was something of the nature like, well, you could tax it eventually, and so nowadays, of course, we do pay for electricity, but at the time it was kind of hard for them to envision what electricity might be used for, but now it's hard for us to imagine what we do without it. So anyway, that answers 17 and 18. So you will have those two questions at least. And then the other question that came up was similar. It says, how many questions on electricity and magnetism are there going to be? And I'm going to try to really limit that because it was a short section. And I've given you two that are going to be on there already, like 17 and 18. Besides those two, maybe just a couple more, maybe having to do with circuits because you guys were looking at circuits. So, just be sure to check those chapters in your book. But we're talking about really big ideas here, nothing really minute or really specific to that chapter. So don't worry too much. There's only going to be a few questions on electricity and magnetism, and I've kind of shown you two already. So that answers that. Someone asked about waves, how big a part of the final are waves going to be. So waves was actually the first unit we looked at. It was waves and periodic motion or harmonic motion. And so, right now the final is shaping up to be somewhere around 50 questions, and waves will probably be about 10 of those questions. So realize in waves, you've got several things. You've got harmonic motion, you've got waves, and a big part of the waves we talked about was sound and light. We've also got these other behaviors as well we talked about, like reflection, refraction, interference, resonance, and so on. So you just kind of want to familiarize yourself again with those. But you'll notice on 19, getting back to that first question, it asks about a sound wave. And this is something you should be able to answer. So one thing I'll just kind of clarify again is we have something. Let's first look at the difference between mechanical and electromagnetic. An electromagnetic wave is another way of saying a light wave. So that's what that means. A mechanical wave is basically a way of saying any other wave besides light. So you got that first distinction, waves that are not light or waves that are light. And then you've got transverse and longitudinal. You might remember that transverse waves look like what we think of as waves. So when I scroll up here and look at this, this is what a transverse wave typically will look like. It has that motion that you might see of a wave at a beach. So the key characteristic there with a transverse wave is that the wave may be moving from left to right, but the particles themselves, if we could actually look at a dot on this string, and we looked at one of those simulations again, that dot is actually going to be traveling up and down, which is perpendicular to the direction that wave travels. So I'll actually pull that up really quick here if I have time here. Sound and waves, and here it is, wave on a string. So you might remember when you did this simulation, this is a transverse wave, because as you watch this wave travel, and we'll go in slow-mo here, the wave is traveling from left to right. Let's make this no end, so it's going to go out the window. So you'll notice that if we look at any individual dot, like this green dot, it's actually traveling up and down, which is perpendicular to the direction that the wave is traveling. That's what it means to be a transverse wave. So that's a transverse wave. A longitudinal wave is harder to visualize. Sound is a transverse wave. So we're talking about, and really, to kind of visualize sound again, it's like a slinky, right? It's got these areas of compression and these areas of rarefaction. And so this is asking about a sound wave. So the answer is B, because a sound wave is mechanical, meaning it's not light, and it's longitudinal. It actually travels like a slinky, as if you were to press one end of the slinky toward the other end. So hopefully that kind of helps describe 19. You should have been able to answer 19. You just got to go back and kind of review what you've done there. So there's some questions answered. Another question was Scantron. Originally I was going to put this on Scantron only because I'm not there, but I haven't really had time to set that up either. I'm sure it's not hard to set up, but the bottom line is I will not put this on Scantron. So it'll be like all the other tests and quizzes. You can write on it and not worry about filling in the bubbles. So no Scantron for the final. What else we got here? Some question asked about, somebody again asked about the generator effect. So going back to 17 and 18, so hopefully I've answered that. But again, generator effect simply means that a magnetic field is producing an electric field, which is just another way of saying that if you have a magnet moving, you can produce electricity. And this is how electricity is generated today. So, if you go to a power plant, whether it's hydropower at a dam or some other power plant, they'll have these big turbines that have inside of them magnets and coils of wire, and that's all that's happening. As that water falls, it's turning that turbine, it's moving magnets past wire, and that generates electricity for thousands of places. So that's how that works. Extra credit, I will have at least one extra credit, and the one I have in mind you've actually got to do after the final. So after Friday, when 6th period has finished the final, I will post at least one extra credit question on the web page for the class. So you can go back there and check for it and then answer it. If I think of other things, I'll try to put it on there, like the last one. Really, in general, I'm not trying to do so much extra credit that you guys can inflate your grades artificially. That's not the point of extra credit. Usually with extra credit, what I like to try to do is try to push what we're learning about already, just to see if you can kind of extend what we're learning about, challenge you. And then sometimes I ask, like the last test you took with the movie you watched, there I'm just kind of making sure, are you paying attention? Are you kind of watching the movie and comprehending what was going on there? And sometimes there are little things like what celeritas means in Latin. That's kind of just something, again, paying attention and noticing. But there's some other ones that are a little more, trying to get you to kind of comprehend and think about. So anyway, those are the kind of extra credit questions I try to think of usually, is something along those lines. So there will be something, at least one question, maybe more, we'll see. How many points? Right now it's looking about 50 questions, so that's going to be about 25 points. So it's a little more than the other tests have been. That's the way it was first semester as well. So pretty similar to first semester. Next question had to do with if you're close to a higher grade, will I round up your grade to that higher grade? And I think we talked about this before first semester, and this is something that I've kind of modified over the years. When I first started teaching, I did kind of feel like it was my duty to do that. But as I've started to teach more and more, I do give students the opportunity, for example, to retake tests. So it really depends on a lot of factors. It's something I looked about individually. I really don't consider it unless we're talking really close, like less than 1%. It does happen sometimes where people are like hundredths of a point away from the next grade. So definitely in those cases, I'll kind of look at that person and kind of consider, but it's no guarantee. I just got to see what you've kind of done. Have you made the effort to actually try to improve your grade? So again, it's nothing I can say for everyone yes or everyone no. It just kind of depends. But I will say, it's pretty rare that I'll actually bump someone's grade up, because there have been opportunities along the way for you to actually raise your grade yourself. So, last question then has to do with the basis of light bullet. So I'll try to explain that. So let's go ahead and take a look at that really quick here. Basis of light bullet. Here it is. So we're talking about waves. And at this point, when we talked about waves, we hadn't really gotten into chemistry yet. So we kind of didn't really touch on this. But then I did say it comes up in chapter 12 as well. And you'll notice in chapter 12, we had this idea with the spectral lines, that as atoms, as matter absorbs light or absorbs energy, it's going to emit energy based on how, those electrons are rising and falling within the energy levels. And so that's all that means, is that when we first talked about light, we really didn't talk about the basis of light. Where is light coming from? And that's really, again, where it's coming from is matter itself. So nothing really key there. It's just tying in waves into chemistry a little bit. So the things that we've covered in second semester do tie into each other. Electricity and magnetism, of course, tie into electromagnetic radiation, which is light, and light ties into matter, and so on. So a lot of these things start to get tied in together, and that's why I wanted you guys to watch that movie, is because it starts to kind of put some things together that Einstein realized that at the time people didn't know. And so of course now we know that there's a lot of relationships among these things you're learning, where it may not seem like it at the time, like, oh, these are like separate things, but really they do kind of tie together. So anyway, hopefully that helped kind of explain some of your questions. If you have more questions, email me and I'll either respond via email or make another screencast before the final. Good luck.